Have you ever held an idea in your hand? Imagine taking something that once existed only in your imagination, and suddenly, it's right there. Tangible, real, and ready to use. That's the wonder of 3D printing. That's what 3D printing lets us do. It bridges the gap between creativity and reality, making it possible to turn digital dreams into physical objects you can touch and feel. It takes a digital blueprint, an idea crafted on a computer, and turns it into a real, three-dimensional object. The printer builds it up, layer by layer, using plastic instead of bricks, almost like magic unfolding before your eyes. This is called additive manufacturing, and it's revolutionizing how we invent, design, and create. From rapid prototypes to custom tools, it's changing industries and empowering individuals to make what they need, when they need it. Today we'll break down this fascinating process using the Bambu Lab A1, a modern, fast, and accessible 3D printer that brings professional quality printing into homes and classrooms. We'll see how it transforms a simple spool of plastic filament into something real and useful, moving step by step from a digital design on your screen to a finished object you can hold. The Bambu Lab A1 is precise, fast, and smart. It manages leveling, temperature, and even color changes automatically, so you can focus on your ideas instead of the technical details. We'll follow a single instruction as it travels from your computer to the printer, watching as digital commands become physical movements, and each new layer of material brings your creation closer to life. By the end, you'll see the science and engineering behind the magic, the precise mechanics, the clever software, and the innovation that makes it all possible. Let's dive in and discover the ghost in the machine. Let's begin this journey into the world of 3D printing, where imagination truly takes shape. The Bambu Lab A1 uses a process called fused deposition modeling, or FDM for short. This is a fascinating technology that has revolutionized how we create objects, both at home and in industry. FDM is by far the most common 3D printing method you'll find today. Walk into any makerspace or tech workshop, and you'll likely see several of these machines humming away, building objects layer by layer. Imagine a hot glue gun, but with incredible precision and control. Solid plastic filament is fed into a heated nozzle, where it melts and is carefully drawn out in ultra-thin layers, one on top of the other. Each new layer of melted plastic fuses seamlessly to the one below it, gradually building up the object from the ground up, almost like constructing a building, floor by floor, but on a miniature scale. One of the greatest strengths of FDM is its versatility. There are many types of plastic filaments available, each with unique properties. For example, PLA is rigid and easy to print, while TPU is flexible and rubbery, perfect for parts that need to bend. The Bambu Lab A1 can even switch between different materials or colors during a single print. This means you can create objects that combine hard and soft parts, or even multiple colors, all in one seamless process. The process is simple but ingenious. Feed solid filament into a hot nozzle, melt it down, and then draw out the shape you want, following a digital blueprint. After each layer is drawn, it cools and solidifies. The print head then moves up slightly, ready to lay down the next layer. This cycle repeats, building the object up, layer by layer. After hundreds or even thousands of layers, what started as a spool of plastic filament is now a finished, tangible object, ready to use, display, or even sell. Thanks to advances in technology, modern printers like the A1 are faster, more reliable, and easier to use than ever before, making high-quality 3D printing accessible to more people. In FDM printing, the material is your ink, and your imagination is the only limit. From toys and tools to prototypes and art, the possibilities are truly endless. That's the core of FDM, building strong, functional objects by fusing layer upon layer of melted plastic. But how does the printer know what to make? Next, let's explore where the instructions come from and how your ideas become reality. Every 3D print begins with a digital model. This can be something you design yourself in CAD software, carefully crafting every detail, or a model you find and download from one of the many online 3D model libraries. These digital files are the blueprints for your creation, containing all the geometry and structure needed for the final object. However, your 3D printer can't interpret these files directly. It needs a translator to convert this digital information into something it can understand and execute. That's where the slicer comes in. Slicer software, such as Bamboo Studio, takes your digital model and virtually slices it into hundreds, sometimes thousands, of ultra-thin layers. Each layer represents a single pass of the printer's nozzle. The slicer then calculates the precise path the nozzle must follow for each layer, transforming a static 3D shape into a set of dynamic, step-by-step instructions. This process is crucial for accuracy and print quality. Beyond just slicing, the software lets you adjust important settings like layer thickness, which affects both the strength and detail of your print, and infill patterns, which determine how solid or hollow your object will be. It also automatically generates support structures for overhangs and complex shapes, ensuring your model prints successfully without collapsing or warping. Once everything is set, the slicer exports the instructions as a G-code file. G-code is a special language made up of precise commands that tell the printer exactly what to do. This G-code tells the printer where to move the print head in 3 dimensions, X, Y, and Z, layer by layer, building your object from the ground up. It also controls how much filament to extrude at each point, and at what speed, ensuring every detail is captured and the print is both strong and accurate. This G-code file becomes the script that the Bamboo Lab A1 follows, step by step, to transform your digital vision into a physical object right before your eyes. In essence, the slicer is the vital bridge between your imagination and reality, turning creative ideas into tangible results. Now, with the instructions ready, let's follow the journey of the filament as it brings your model to life, one layer at a time. The filament is the printer's raw material, a thin plastic strand wound on a spool. It travels from the spool holder through low-friction tubes to the extruder. The extruder's gears grip and push the filament with precise force, following the slicer's instructions. The A1's direct drive extruder gives responsive, accurate control, crucial for quality prints. Sensors detect tangles or runout, pausing the print to prevent failure. Reliable filament feeding is essential for perfect prints. Next, the Hotend melts the filament. The Hotend is where solid filament becomes molten plastic. It's a tiny furnace. The heater block melts the filament, while a thermistor keeps temperature precise. The melted plastic is forced through a small nozzle, which determines the width of each line. The Bamboo Lab A1's all-metal Hotend handles high temperatures and quick nozzle swaps. Too cold, and the filament jams. Too hot, and it oozes or burns. The Hotend's design is key to print quality. Every part, the heat break, heater, thermistor, and nozzle, must work in harmony. This is where the magic of melting happens. Now let's see how the printer moves with such precision. The printer's motion system uses X, Y, and Z axes, just like a 3D graph. The tool head moves left, right, and front back, while the build plate moves down after each layer. Metal rails and stepper motors ensure fast, accurate movements. The A1's firmware translates G-code into millions of tiny, precise steps. This mechanical ballet builds objects layer by layer with micron-level accuracy. Features like noise cancellation keep the process smooth and quiet. Every movement must be perfect for a clean final part. The result, a flawless dance of mechanics and code. Now, let's print the first layer. Printing begins with the first layer, the foundation of the entire object. The nozzle lays down molten plastic, which must stick firmly to the build plate. Special surfaces like textured PEI help with adhesion and easy removal. Each new layer fuses to the one below, building strength and shape. Cooling is crucial. A fan solidifies the plastic quickly, especially on overhangs. The slicer controls fan speed and print pace for optimal results. The A1's firmware even slows down for small layers to ensure quality. Active heat management enables complex, detailed prints. But for all this to work, the bed must be perfectly level. The first layer's success depends on perfect nozzle-to-bed distance. The A1 uses automatic bed leveling. The nozzle taps the bed at multiple points, mapping its surface. The printer creates a digital mesh, adjusting the Z-axis in real time for flawless adhesion. This automation removes the frustration of manual leveling. The A1 also measures vibration, using input shaping to cancel out artifacts and boost speed. These features make high-quality, reliable prints possible for everyone. Bed leveling is now effortless. Next, let's look at the printer's smart features. The Bamboo Lab A1 is powered by smart firmware, the brain behind the operation. It manages temperatures, motors, and sensors, making real-time adjustments for perfect prints. Sensors detect filament runout, tangles, and precise axis positions. Active flow rate compensation ensures even extrusion by monitoring pressure inside the Hotend. Wi-Fi connectivity lets you control and monitor prints remotely, and firmware updates add new features. All these systems work together, making the A1 powerful and user-friendly. The intelligence behind the scenes sets modern printers apart. Now let's see the whole process in action. Here's how it all comes together. Start with a 3D model, slice it, and send the G-code to the printer. The A1 heats up, probes the bed, calibrates, and loads the filament. The print begins. The tool head and build plate move in sync, laying down layer after layer. Sensors and firmware manage every detail. Temperature, flow, speed, and color changes. Hours later, the last layer finishes, the part cools, and you remove your new creation. What began as an idea is now a real object in your hand. The Bamboo Lab A1 combines mechanics, electronics, and software to make this possible. With this knowledge, you can turn your ideas into reality. So, what will you make?